Okay, this is part 2 of the learning how to draw or name organic compounds with alkyl groups and halides. And we have done the problem on the left in the video part 1, and now we're going to continue with the molecule on the right. So as you're looking at that, you're going to want to draw the longest chain, and remember the longest chain does have to include the multiple bond. And I'm just going to show, because it is kind of tough in that video to see that there is a multiple bond between that second and third carbon. So therefore, the longest chain for this molecule would be this. And we are going to count this carbon right here. That would be first carbon, second carbon, this would be third carbon, and so on and so forth. We would count actually from the right to the left because the multiple bond gets the priority of having the lowest number possible. All right, so the last name for this molecule then, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8 carbons in that longest chain. So it would be called a 2-octene. And I'm going to just put a dash in between the 2 and the oct. So that is the last name. Then you start looking at alkyl groups. And what we're going to do is we're going to look at how many methyl groups you have. And we're going to look and say, okay, there's a methyl group here, here, and here. There is 3 of them within that whole molecule, so it's called a trimethyl. And their positions are on the 3rd carbon, and 2 of the methyls are on the 7th carbon. So it would be called 3, 7, 7 trimethyl. And we're going to look at the last alkyl group being branched off of the 4th carbon, and you can see that that is a propyl coming off the 4th carbon, so it would be called 4-propyl. So it's 3,3,7-trimethylpropyl-2-octene is how you would name that molecule. To count up its molecular formula, we have to count up how many carbons we have in the whole structure, but we know we have 8 in the longest chain, so there's 8, 9, 10, 11, 12, 13, 14. Let's see, make sure I counted that right. 8, 9, 10, 11, 12, 13, 14. So C14H28. That would be the molecular formula. So that is how you can have a structure and get to the name when you have branching carbons off of a long chain. The next thing we're going to talk about is that you can have, it doesn't have to be just carbons that can branch off. You can have halogens branching off. So we call them halides, or sometimes they're called halocarbons because they have a halogen branching off as a substituted group. If you see a fluorine branching off of a long chain carbon, we call that fluoro. If you see a chlorine branching off, we call it chloro. If you see a bromine branching off, we call it bromo. And if you see an iodine or branching off, we call it ido. But the naming system is going to be exactly the same. So you're going to look at the last name. Here's my example. I've got 1-chloro, 2-fluoro, 2-methyl pentane. And I'm going to look at that last name right here, which is called pentane. And I know that that is 4 carbons. 1, 2, 3, 4, 5. Oops, I made a mistake. Pent means 5, so that's 5 carbons in pentane. That's my longest chain. Okay, so that means on the first carbon, you're going to have a chlorine substituted instead of a carbon. On the second carbon, you'll notice that you'll have a fluorine substituted. Now this fluorine could be in any position, up or down. I'm just choosing it to put it into that down position. And then you also have on the second carbon a methyl, which means that you've got the carbon one carbon branching off. That is the molecular structure for 1-chloro, 2-fluoro, 2-methyl pentane. If you need to write this molecular formula, the thing that you will do is you're going to write the carbons first. So I'm going to count up how many carbons I have, and I have 6 carbons throughout that whole structure. So this is going to be a C6 because I've got 5 in the longest chain for the pentane, and then there was 1 methyl group. So that gives me 6 carbons total. Then, since it's an alkane, you would anticipate then that to be C6H14 if all of those carbons had hydrogens around them, but they don't. There's 2 halogens that are in place of where there would be hydrogens. So what you do is you're going to cross this out and you're going to say it is C6H12 because I took away 2 of the hydrogens because there's 2 halogens substituted, and then I'm going to just place the halogens behind that, Cl and F. And again, the order doesn't really matter for me as long as you get those halogens in after the carbons and the hydrogens. So that's important. It goes carbons, hydrogens, and then just put in the halogens in the molecular formula afterwards, and that will be fine. All right, let's take a look at the next one, which is 3,3-dibromo-2-pentyne. Now when we look at pentyne, pent again means 5 carbons. You know that there's a triple bond because it ends in YNE, and you know that that triple bond is in between the second and the third carbon. So here is my pentyne that I'm going to draw. It's 1, 2, 3, 4, 5, and the triple bond is in between the second and third carbon, so there's 2-pentyne. And then as a substituted group, we have 3,3-dibromo. Notice that you're using the prefixes again, just like you were for the alkyl groups. A dibromo means that there are 2 bromines within that whole molecule, and the fact that they are on the third carbon is represented by the 3,3. So right here is going to be a bromine, and here is going to be a bromine. So that would be 3,3-dibromo-2-pentyne. What would be its molecular formula? Well, you're going to count up the carbons, and you know that you have 5. You have 5 carbons, and typically those 5 carbons, let's just move this over here. So typically those 5 carbons, if it was a normal pentyne, it would follow the general formula of C to the N, H to the 2, N minus 2, which would give you H8, okay? But you have 2 bromines substituting. So you would then have only 6 hydrogens available and 2 bromines within the molecule. And that's the molecular formula for 3,3-dibromo-2-pentyne. All right, now it's your turn. Time for you to try to draw the structures or name the structures for the following compounds. Then I'd like for you to write your molecular formula for all of those structures. I would recommend pausing this video, trying your work, putting it in your notebook, and then once you are completed, resume the video and you will see the answers on the next slide. Okay, welcome back. I had you try this, this problem, and you'll notice here are the answers. How successful were you? Are you able to draw compounds given the name? Are you able to, given a compound, go to the name and draw the correct molecular formula? If you have any questions, please make sure you ask your teacher why the naming is the way it is. And I hope this video helped. Thanks for listening.